Good afternoon. Today is the May 15, 2020. My name is Rodrigo Siles and I am a student of Anne Arundel Community College, and I'm pursuing the degree in my associate degree in mechatronics. Well, my capstone project is design a cart which is able to control electrical device, high power electrical device and low power electrical device, as for example stepper motors, regular DC motors, like for example this one or this one, or control solenoid valves and also directional control valves. And the main purpose of this project is trying to replace the regular PLCs, which is very well established in the industry. But the disadvantage about the PLCs is the price and also the rigidity, the stiffness and rigidity of the software they need to handle. So I am proposing an alternative to this system, design this electronic card. So to begin, I divide the project in 3 stages. First, the power stage, the control stage, and also the insulator stage, which means I insulate all the data and all the power, the external power from the computer, from the information component, in order to prevent filtrations and noise. So, and also I is 1, 2, 3, and 4. All these 4 cards goes in top of each other. I split all those 4 in order to explain in detail what is the function of every single one. So having said that, I would like to start, for example, to prove my claims, and I'm going to begin with my power supply, which I have is designed for 18 volts, 5 volts, and in addition I have a power supply which goes from 0 to 36 volts. So I would like to prove and show the values what I achieve in that. So allow me to do that. In order to do that, I will connect my read meter or my voltmeter, and I'm gonna start with 5 volts. Let's see what we have for 5 volts. We have right there, we have the proofs. Right there, 5 volts, oscillating between back and forth. So once I have it, I will disconnect the power from 5 volts, and my goal, I'm going to go to the 18 volts. There you go, connected. So let's see the power, 18 volts, between 18 and 19 is oscillating. So having said that, I finished proving that this power supply is to feed the power for this directional control valves, for the solenoids and the electro-pneumatic valves. Well, now the next step is, for example, explain the how works this card what I designed. It's specifically designed for another specific project, which is has another purpose. But let me take care, or let me explain this card with this example. I create the project was designed, and the part of the project was design a testing system. So what I did is I create a row of through four H bridge controller to control any type of motor, right? No, any type. I'm sorry, to control the DC motors. direct current motor. So I have the four. What I'm gonna do is test all these four chips in one by one in a sequence. And in order to test one by one, I make a special program, a special sequence using Arduino Omega, right? And here is part of the code. To control such motors. Well, then I will make a deep explanation or a detailed explanation of this card, which is in charge to control, for example, turn on and off any AC motor. See what it means if I have energy coming from 120 volts from the power company. I can use that to turn on and off without having any problems about the malignant problem with the noise and all these problems we usually have when we work in a industrial environment. So having said that, I would like to prove my concept, beginning with turn on this motor first, and then I will turn on this motor first, and I will when I'm gonna turn, what this motor is going to do is go down and up, yeah, in a very refined movement, which is calibrated. It was designed just for this machine. Same thing. I will proceed with this motor, and I will turn the motors in such a way the pendular wheel is going to go between 35 degrees, between 0 and 35 degrees, right? Or if you want 17 degrees in the other side, in the clockwise 17 degrees, in the anti-clockwise minus 17 degrees. So let me plug up my Arduino. So let me power it up and see, and let's begin to see the system working. As you can see, the motor start to begin the first movement. Let's see the detail right there. Right there. I would like to make also some comments about this machine. It has a special value for me because this machine was designed with the purpose to create microvalves or create artificial human organs, as for example kidneys or hearts. I believe it's a little bit ambitious, and the project in C is very ambitious, but at the same time I think it's doable. So let's begin and see the movement of the wheel, the pendular wheel. See, now I'm gonna give you another view, which is gonna describe with more precision that how precise and slow is the movement. It's almost undetectable. Because it was refined. The program I used the system. It was designed to make a small, discrete movements, and that's what I got. So let me show you what part of the system is working right there. See, you have the second motor. It's gonna stop and then it's gonna come back again. I think it's in the process to come back. Now, as you can see, the motor start to come back. permission, please, to ask you a few minutes to unplug these two systems to plug the another two bulbs or the another two stepper motors. Okay, he's gonna stop them shortly, and there you go. Thank you. So let me unplug the system and I will come back and show you. There you go. See? Now let me plug the system right there. See, red and red, blue and blue, yellow and yellow. So let me unplug the other one and plug to the other side. So let me do this movement. Very good. Now I think I'm ready to make the next demonstration. Right. So again, I'm gonna pick up the Arduino. I'm gonna plug in the system, turn the power on, and start the next two motors. Testing the next two motors. Let's improve the efficiency of the. There you go. That's begin the. I would like to express my infinite gratitude to all the staff from the school, from around the community college. Especially, I would like to show my appreciation and my infinite gratitude to my mentors, the professor Peggy Walton, Tim Callahan, and James Sherman, and also a special gratitude to Mark, the lab assistant, who was having give me a lot of advice on how to cut and use the laser cutter. As you can see, I have very slow moving in these motors. So let me take a look at different parts of view. I designed this very interesting grip in order to hold the equipment. This radial grip, so you can hold any type of element or tool if you want. Even if I can use a sheet and start to engraving the micro valves material. So let me show you in detail the process. As you can see, the models are okay. Okay. All these models that are in the program are especially designed to certain levels of inertia. As I use the power supply to control the amount of current and voltage to overcome to more or less be in the range of a good control system. So that's the first part, for example, of my demonstration. And also I would like to give you another tour about how works the system. I have the power supply. Yeah, I built a small power supply. When I built this model, I ran with so many problems. The main problem was the generation of heat. So I have been forced to to use to build and calculate a special power supply, which is right here. As you can see, I have to improvise the heatsink, and fortunately all the systems start working properly. Here is the H-bridge controllers, and here's I have the opto insulators and the LED lights which tell me which system is working. Here I have the high power high power relays. So I make one more demonstration and then I will turn off the system. So now here, after I finish this cycle, I have to reconnect and clock up the system and the high power supply. So that way you can see, for example, control this type of valves, right, which I modify, and see if I can control this directional valve. So I make a small variations. Now I have a directional valve embedded into a cylinder. I know it's a little bit big, but I didn't have the right equipment to minimize and miniaturize the system, but I think it's going to work. So let me see this last process. Now it's coming back. Now it's coming back. So in short, it's gonna finish, which is conclude the first part of the video and the demonstration. See? I would like to thank again to all the staff, to my mentors, in general to the Professor Elizabeth Byrne. She gave me the opportunity to study in the school. It's going to stop shortly according with the program. There you are. Thank you.